So, if you look at Markovnikov and anti-Markovnikov addition, the Markovnikov addition starts by the addition of H plus ions. So, this is the electrophile which adds in this particular reaction. So, the electrophilic addition leads to a stable carbocation. So, in this particular case, when the hydrogen adds to the terminal carbon, the internal carbon becomes more stable. So, that is how the general or the normal Markovnikov addition actually proceeds. But in the case of anti-Markovnikov addition, we are not seeing H plus and X minus addition, it is basically H dot and X dot addition. Basically, the reaction mechanism completely changes if we use a peroxide. Let us say if we use hydrogen peroxide. So, this reaction mechanism completely changes, because of which we have two radicals which are involved in this particular reaction, and the X dot actually adds first. When instead of hydrogen, the halogen is the one which adds first to the alkene. So, when the halogen adds to the alkene, the internal carbon radical is formed. We can follow the same thing, whether it is a electrophile adds or the radical adds, the more stable species is the one which should result in that particular reaction. So, when H plus adds, we get an internal carbocation which is stable. When X dot adds, here in this particular case, the X dot adds to the terminal carbon again, leading to the internal carbon radical which is more stable. So, that is the reason this reaction proceeds exactly in the opposite way. That means, in the normal Markovnikov addition, hydrogen adds first. In the anti-Markovnikov addition, the halide, the X dot radical adds first. And the next step is basically the addition of hydrogen radical, which gives the final product. So, what are the two differences between Markovnikov and anti-Markovnikov addition? So, here what species adds first, and whether it is a radical or the proton. So, that is what makes the difference. In the Markovnikov, H plus adds, in the anti-Markovnikov, X dot adds. So, what is the Markovnikov rule? When an unsymmetrical alkene reacts with the hydrogen halide to give an alkyl halide, the hydrogen adds to the carbon of the alkene that has greater number of hydrogen substituents, that means less branched carbon, and the halogen adds to the carbon of the alkene with the fewer number of hydrogen atom, that means more branched carbon. So, this is what is the Markovnikov rule. And when we look at reactivity and regioselectivity of the Markovnikov addition, according to the Markovnikov rule, we get the different type of product. So, in the case of alkene addition, propylene actually when HCl is added, we end up with a secondary carbocation which is more stable, gives the final product or the major product. Similarly, when isobutylene undergoes a reaction, the tertiary carbocation is more stable than the primary carbocation. So, the tertiary carbocation leads to the final tertiary butyl chloride as the final product, which is the major product. So, this is how we can actually control the reaction is being controlled. And when we look at 2-methyl-2-butene, this actually can this does not give a product from the secondary carbocation, but this gives a product from the tertiary carbocation. So, this is also another example to tell how the reaction actually proceeds, because this secondary carbocation can undergo rearrangement to a tertiary carbocation, because two possibilities are there. If the proton adds to the gem dimethyl carbon, we get secondary carbocation, the bottom image. If it adds to the other carbon, we get the tertiary carbocation, the top image. Of course, the secondary carbocation can also undergo proton shift to give the more stable tertiary carbocation. So, this stable tertiary carbocation gives our final product, which is the tertiary pentyl chloride, as shown here. This is the major product. So, this is again based on the stability of the carbocation. Of course, if we talk about basically the peroxide effect, this is also called as Karash effect. So, in this particular case, you will be actually wondered how the peroxide effect was identified by Professor Karash. So, he had actually carried out close to 500 different types of well planned and systematic reactions by changing reactant, reagent, rate and reaction conditions he had studied. So, and he also had a very good knowledge about free radical reactions. So, all these things are actually responsible for him identifying the peroxide effect. In fact, the identification of peroxide effect actually was a accidental discovery, so to say, because he was not at all doing any electrophilic addition reaction, but he was actually carrying out a very different reaction, and he found out this by an accident only. So, the presence of a small amount of peroxide in the allyl bromide he was using led to the discovery and the mechanism of actually the anti-Markovnikov addition.